In the second part of section 6.2, we are going to use the unit circle that we created, and we're going to see different ways on how we can use that unit circle to help us solve some problems. All right, so I'm just going to bring in and out the unit circle to use as a reference. All right, so in example 1, it says, given the x and y coordinates on the unit circle, find the exact values of the 6 trig functions. All right, so the 6 trig functions, remember, are sine, cosine, and tangent. And then we have cosecant, secant, and cotangent. Now, I kind of put these in a specific order. We're used to sine, cosine, and tangent. And then I want to mention that tangent and cotangent go together. That means they're reciprocals of each other. And I want to point out that notice I have sine and cosine, cosecant and secant. A lot of people would want to put the sine and the secant together and the cosecant and cosine together, but it's actually the opposite. All right, so if I think about it in terms of the 6 functions, this one is usually CSC. That's what I should have wrote there. And this one is SEC. But think of, you have to have an S and a C in each one. So if you have sine, you have to match that with cosecant. Okay, so the cosecant is the reciprocal of sine. If you have a C here, you have to have an S as the reciprocal. So cosine and secant are reciprocals of each other. All right, so in part A, it gives us an ordered pair, and it says to find the exact values of the 6 trig functions. Well, it will be helpful to know what this angle is. All right, so if I look at this, a couple things I'm going to notice. I have a square root of 3 over 2 and a 1/2. So I know this is either, and by the way, this is in quadrant 1 because both of these values are positive. All right, so this is either a 30-degree angle or a 60-degree angle because I don't have the square root of 2 over 2 for both of these like a 45-degree angle is. So I'm looking for square root of 3 over 2 and 1/2. So if I bring in that unit circle, the square root of 3 over 2 and 1/2 is a 30-degree angle, or pi over 6. All right, so I'm just going to label that. So this one is 30 degrees, or pi over 6. So that's the angle that we're referencing here. And now it's asking us to find these 6 trig functions. So I'm going to have sine and cosine. Now we get those values from our ordered pair, because remember, in our ordered pair, cosine goes first and sine. Okay, so this is our x coordinate, this is our y coordinate in our ordered pair. So now, looking at this, I know cosine is the x-coordinate, so this is square root of 3 over 2. Sine is the y-coordinate, which is 1/2. Now, tangent is y over x. So this means I have sine over cosine. So if I sine is 1/2, over my cosine, which is square root of 3 over 2. If I have 1/2 divided by square root of 3 over 2, I flip, multiply by the reciprocal. So I have 1 over the square root of 3, which is the square root of 3 over 3 if I rationalize. All right, so I had to do a little division here. But now I have the cosecant, which is the reciprocal of sine. So this is just 2 over 1. Cosine goes with secant, and the reciprocal of cosine would be 2 over square root of 3, which would be, if I multiply by the square root of 3 over square root of 3, I'm going to get the square root of 3 over, or 2 square root of 3, sorry, over 3. And then cotangent is going to be the reciprocal of this. So this is really just going to be the square root of 3. This is 1 over square root of 3. So this is just going to be the square root of 3 over 1, or the square root of 3. All right, so there are the 6 trig functions. All right, so now we're going to look at part B. We have 2 square root of 2 over 3. Now, this is a point that's on the unit circle, but we don't have it labeled here. So we don't know what the reference angle is going to be. Remember that first number was 2 square root of 2 over 3. So I don't have any of those cosine values here, but I still am going to be able to find the 6 trig functions, because I know that cosine is my first value and sine is my second value. So sine is negative 1/3 and cosine is 2 square root of 2 over 3. Now for the other trig functions, I'm going to do the, for tangent I have to do the division. So I have sine over cosine. So tangent equals sine over cosine. So this is, sine is negative 1/3 over 2 square root of 2 over 3. Now this would be, if I notice here, if I multiply the top and the bottom by 3, the 3's a cancel. So I have negative 1 over 2 square root of 2. And now I need to rationalize that denominator. So if I multiply by the square root of 2 over the square root of 2, I'm going to have negative square root of 2 over 4. Okay, so this is my tangent. So now let's do cosecant, reciprocal of sine, CSC. So the cosecant of this angle is going to be the reciprocal of negative 1/3, which is negative 3. The secant is the reciprocal of cosecant, which is 3 over 2 square root of 2. And if I multiply top and bottom by the square root of 2, I have 3 square root of 2. And multiply this by the square root of 2, that gives me 2 times 2 is 4. And then I need cotangent. So cotangent is going to be the reciprocal of tangent. Well, if I look at this part in my tangent, I flip it around. I'm going to have 2 square root of 2 over negative 1, or just negative 2 square root of 2. Now I could have flipped this, but I would still have to rationalize the denominator, but it's easier to just work back with this one. So before I rationalized this denominator to get this, if I flipped this part over, I now have my cotangent. All right, the next one is cosine of 5 pi over 6. All right, so first of all, it's asking us for all 6 trig functions. And I'm going to use the unit circle. So I'm going to find cosine of 5 pi over 6. All right, so if I look at this and I find 5 pi over 6, okay, so 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, here's 5 pi over 6. So 5 pi over 6 is the same as 150 degrees. So I'm going to write that down. So this is 150 degrees for 5 pi over 6. Now I'm going to find all of my trig functions, even though it just says cosine. So sine, cosine, tangent. And then we'll worry about the next ones in a minute. So back to that 5 pi over 6. My sine is going to be 1/2, and my cosine is going to be negative square root of 3 over 2. All right, so 1/2 for sine, and negative square root of 3 over 2 for cosine. Now tangent will be 1/2 divided by negative square root of 3 over 2, which gives me negative 1 over the square root of 3. And if I rationalize the denominator, multiply the top and bottom by the square root of 3, I get negative square root of 3 over 3. So that's the tangent value. Now we have cosecant going with sine. So cosecant of 5 pi over 6 will be the reciprocal of 1/2, which is 2. Secant will be the reciprocal of cosine, which is negative 2 over the square root of 3, or negative 2 square root of 3 over 3, rationalizing the denominator here. And cotangent is the reciprocal of tangent, so I'm going to turn this around, but actually if I look back up here, I won't have to rationalize the denominator, so I'm just going to have negative square root of 3. All right, so now what it's asking us to do is to find the exact value without a calculator. All right, so actually all of these ask us to find exact values. So in all of our examples, they want exact values, not a calculator value. So if you're asked for an exact value and you give me a decimal, it is automatically wrong. Even if your decimal is close or rounded off correctly, an exact value is not rounded off. So no decimal values when it asks for exact answer. All right, so first of all, when it says to find the exact value, we're going to use our unit circle, but if I try to find an angle that says 11 pi over 2, we're not going to find it on here because our unit circle is confined to values between 0 and 360 or 0 to 2 pi. And 11 pi over 2 is more than 2 pi. So what I can do is I can add and subtract if I need to, add or subtract values of 2 pi until I get to something between 0 and 2 pi. All right, so if this is 11 pi over 2 and I subtract 1 full revolution around the circle because 2 pi is 1 full revolution, so I want to find out where would this fall on the unit circle. So if I subtract values of 2 pi, and because I have this measured in halves, I want a common denominator. So 2 pi is the same thing as 4 pi over 2. That's going to get me to 7 pi over 2, which is still bigger than 2 pi. So I'm going to take, so I just want to point out, this is 2 pi. So it's just a revolution around the circle. So I'm going to take 7 pi over 2, and I'm going to go another revolution around the circle. So I'm going to subtract 4 pi over 2, and this gives me 3 pi over 2. And this is the same angle as 11 pi over 2. So now what we want to do is we want to find sine of 3 pi over 2. So I'll bring in the unit circle. 3 pi over 2 is right here, and the sine value is the y-coordinate, which is -1. So sine of 3 pi over 2 is -1. All right, now how about sine of -3 pi? All right, so this is a negative value. We want to add multiples of 2 pi to get it to where it will land on our unit circle. So if I have -3 pi and I add 2 pi, I still have -pi. So I'm going to take that -pi and I'm going to add another 2 pi, just revelations around the circle, and then that would be pi. So now -3 pi is the same coterminal angle as pi. So now I can look for sine of pi, and on my unit circle, pi is 180 and the sine value is 0. So sine of pi or -3 pi are both 0. All right, so now we want tangent of 6 pi. All right, so here I'm going to take 6 pi, I'm going to subtract 2 pi, and I get 4 pi. I'm going to subtract 4 pi, and I'm going to take 4 pi, subtract 2 pi, and get 2 pi. So we know where 2 pi is on our circle. 2 pi is right here. So this is a 0 or 360 degrees angle. So we want to find now tangent of 2 pi. Now remember, tangent is sine over cosine. So for our 2 pi, my sine value is 0 and my cosine value is 1. And that's going to be 0. And last but not least, I need cosine of -3 pi over 2. All right, so -3 pi over 2, let's find our angle that's on the unit circle. So I'm going to have -3 pi over 2, and I'm going to add a full revolution around the circle, which we did over here. This is 4 pi over 2. Okay, so if I have -3 pi over 2 plus 4 pi over 2, my denominators are the same. This is still 2 pi. So this is going to be pi over 2. 1 pi over 2. And that is on our unit circle. Pi over 2 is the same thing as 90 degrees. And what am I looking for here? I'm looking for cosine. So I have cosine of 90 degrees and that value is the x-coordinate, which is 0. All right, so here we just got to make sure that our angle that we're looking for is on the unit circle, and if it is not, then we're going to add or subtract values of 2 pi to find a similar angle that is on the circle. All right, so example 3 says we're going to find the exact value without a calculator. So we're going to do some calculations here with sine and cosine. So first it asks us for sine of 45 degrees. So I can look at this, 45 degrees, cosine sine. Sine is 2 square root of 2. I'm sorry, square root of 2 over 2. And cosine of 60, 60 degrees is here. Cosine is 1/2. So cosine of 60 is 1/2. I have a common denominator, so I can combine these, and this is 1 plus square root of 2 over 2. That's the value of cosine 45 plus, I'm sorry, sine 45 plus cosine 60. All right, so part B, tangent of 45 times cosine of 30. All right, so let's look here. 45-degree angle, tangent is y over x, and because they're the same thing, I have the square root of 2 over the square root of 2. Now let me say that again. Yeah. Square root of 2 over 2 over square root of 2 over 2, which is just 1. And then I have cosine of 30. So 30 degrees, cosine is the first coordinate, so I have square root of 3 over 2. And when I multiply these together, I just get square root of 3 over 2. And the last one, I have sine of pi over 4. Pi over 4 is here. Sine is square root of 2 over 2. Plus cosine of pi over 4. Pi over 4, cosine is the first coordinate. So I have the same value. Add these together, common denominator stays 2. And I have 2 of these, so I have 2 square root of 2 over 2.